Okay, so in this video I'm going to do a problem which is a bit different to sort of the standard ones, and just so you're aware, in questions like the one that I'm about to do here, the book will typically step you through it, so it'll take you through the process, one bit at a time. I'm going to go through the whole thing here and see how this is done. So find the exact area between the curve that and the x-axis between x equals 0 and x equals 1. Now, there's a couple of things to take note of here. First off, I'm going to sketch this. So log e of x plus 1, well, it's moved 1 unit to the left. It would normally have an asymptote at x equals -1. It's going to pass through the origin, so that's an important point, and it's going to go off in that sort of a direction. And it's between x equals 0 and x equals 1, so let's say this here is 1, then that there is the area that we are looking for. The problem with this question is that we can't easily anti-differentiate the log function, or we're not familiar with the antiderivative of the log function yet. So we need another way around this, and this is a really nice bit of maths in my opinion. So what we actually do is we use the inverse of this. Okay, so I'm going to find the inverse. So to do that, we swap x and y, where y is f of x. So I get x equals log e of y plus 1, which that means e to the x equals y plus 1. So taking away 1 on both sides, we get y equals e to the x minus 1. So therefore, the inverse function is equal to e to the x minus 1. Now I can sketch that. I'll do this in a different color as well, but it's going to go something like that. I don't believe these here would actually intersect here. That's just my drawing being a little bit off. So it's meant to be sort of just above the curve there. But what this means is that this area here is going to be the same as this area in here. Okay, so I should also put the value here, so that there is just a value of 1. Now, a couple of other things we need to do here, okay, because to do this question I'm going to need to know this point right here. So I can find out what the x value is when y equals 1, or alternatively I could just find out what the y value is when x equals 1 for this here, because it's just going to be swapped for the inverse function. So when x equals 1, f of 1 is just going to be equal to log e of 1 plus 1, which is log e of 2. So this height here is log e of 2, which means that this x coordinate here is also log e of 2. Right, so there's just one more thing that I need to do here really, and that is to actually get the area in here. Now to get this area, this is between the graph and the y-axis. So what I kind of need to do is I need to make a rectangle here, okay, this whole rectangle, so sort of going down there. I can get the area of that rectangle, and then I could just take away this part here, and that would leave me with the bit that I actually want in red. So what I'm going to do is I'm going to say that the area is equal to, now the area of the rectangle has a width of log e of 2 and a height of 1. So the area of that is just going to be log e of 2, because you do length times width. Log e of 2 times 1 is just log e of 2. Then I need to take away the area beneath this red curve here, so that is the integral between